Good morning, students. So we'll move on to the last topic of the assembler, that is assembler design options. Okay. So you may be wondering, like, why we need to study regarding assembler design options. We already studied one-pass assembler, two-pass assembler, multi-pass assembler. Okay, we studied regarding all the functionalities or all the features. Okay, so that which is helpful for the conversion of the assembly level language, which we are calling as a source program, into a hexadecimal object code, right? Okay, we discuss all the basic concepts of assembler design, like what all the components are involved in assembling and all. Okay, in today's session, we will be discussing like regarding one-pass assembler and regarding multi-pass assembler or two-pass assembler. So two-pass assembler we will be discussing in the next session. Okay, so in today's lecture, we'll be concentrating on one-pass assembler exactly. Okay, so now here we need to chalk out what we are going to discuss regarding main target. Okay, regarding what exactly. So this discussion, assembler design option, is targeting for. So here we are discussing the structure and logic of one-pass assembler. Okay, like what exactly the internal structure of a one-pass assembler. Okay, so how it is going to operate, on what logic it is going to operate, regarding that we'll be discussing. Okay, so these assemblers are used when it is necessary or desirable to avoid a second pass over the source program. See, our target, like we are having two different passes for the assembler, right? One pass means first time when we are scanning the complete program, if you are grabbing the complete information, then no need to worry. Okay, we can directly go for the execution of the program. But sometimes we have a problem of a forward reference. Okay, whenever we have such type of a forward reference problem, so we need to go for the multi-pass. Okay, means the second time we need to go for the scanning the program exactly. So it is not at all compulsory like the program must go through the one-pass assembly. Okay, and both one-pass assembly and multi-pass assembly exactly. In single pass or in one pass, if your program operand, every operand, whatever we are mentioning, okay, if your assembler finds all its original value, then no need to go for the second pass. Yeah, the logic of working of this pass assembler will be what? Like we are scanning the complete program line by line. Okay, so what all the operands in mnemonics and all that will be already predefined. Okay, like operation table will be having there already, it is existing. No worry about that. Okay, but the operand places and the labels, whatever you are using, so these two component original address we need to identify. Remember this. For this, what we are doing, we will be scanning the entire program and we will be retrieving the original value, and same thing will be updated in the symbol table exactly. Okay, so now during the first pass, if you are unable to find, few values of those operand, then what we do, we go for the second pass exactly. We go for second pass. Sometimes what happens is like the thing will be defined in one location. Okay, but you are referring it in the before version or before location exactly. Then when you are reading that particular previous location, okay, then we will be not having information what is the original value, because the original value is defined in the future exactly. Means in the next line or maybe after a few lines it will be defined exactly. So during that we may not be having clear-cut information. So what we do, we go for the second pass. Okay, their exact information will be available. But now what we are trying to do over here is, okay, with single pass itself, such type of problem, whatever we are facing, that can be resolved. Okay, but we need to go for some change in the logic. We'll see that. Okay, what logic we are going to change, how it will be implemented. Okay. Then notion of a multi-pass assembler and extension of two-pass assembler that allows an assembler to handle forward reference during symbol definitions. The question like why we want to go for the multi-pass assembler or the extended version of the pass assembler. Okay, is what sometimes we may be having the forward references for doing the symbol definition in dot. Okay, so that cannot be handled by the one pass assembler right now. Okay, without any changes. Okay, up to now whatever we discuss regarding the one pass assembler. Okay, with that we cannot achieve it. Okay, but with some alternation, okay, we can go for that. Okay, no problem. So these are the two topics, very important topics we'll be discussing in this assembler design option exactly. One is single pass assembler or one pass assembler, and second will be multi-pass assembler or extended version of two-pass assembler. Now, so we'll begin with one pass assembler. The main problem in designing the assembler using single pass was to resolve forward reference. We can avoid to some extent the forward reference, but these are the following three reasons. Okay, see here, one thing you need to notice. The only drawback of one pass assembler is what? It cannot handle the forward reference. In that, we have a program beginning at. Okay, so there was some small disturbance over there. Here one pass assembler, the main role is what? The problem, okay, what we are facing over here is what? The forward reference it cannot handle exactly. So my example was if program is beginning at location 0, okay, see that we have a location number 50 where we are using one operand, but that operand is declared and defined in line number 100. Yeah, in 50 we are using particular operand, but the operand value is defined in a location called as 100. Okay, then that reference we are calling it a forward reference exactly. Means before we are defining a particular operand, we are trying to use it. Okay, so then during one pass, like line by line, how we are coming. Okay, during first pass. Okay, when you come for 50, means line number 50, you don't know what is the operand. Okay, what you will be having zero knowledge about that. Okay, but when you are coming to the line number 100, then you will get the information like yes, that is what the original value exactly. But you cannot update by going back to particular location. Okay, so what we need to do some such type of alteration. Okay, so that wherever such type of forward references are mentioned in the program, that should be identified first. Okay, like wherever, okay, we need to provide some link for that particular location, like where all these operands are referred, okay, before it is defined exactly. So every address should be available. When you are finding that particular value of the operand, then based on this reference value or the reference address, everywhere it should be updated exactly. Okay, so this is the logic we are applying. Okay, so that will be explained and discussed with example in next slide. Okay, some basic think what we can do for resolving the forward references, eliminating forward reference to data item. Okay, whatever the forward references we are available with, just eliminate it. Okay, by defining all the storage reservation statements. Okay, at the beginning of the program rather than at the end. See, up to now, wherever we were discussing about some program and all, at the end of the program or at the end of the control section, okay, regarding the operand, what all the reservation like reserve byte, reserve word, okay, then buffer and all, or else any other operand, what you are declaring and defining, that was at the last example, right? Then obviously, whenever we are using the program, then it will become forward reference. So that should be eliminated. How? It will be maintained in the beginning of the program. Okay, in the beginning of the program, if it is available, then in the bottom, if you are using that same operand, then it will not be affecting the forward reference. Okay, then unfortunately, forward reference to labels on the instruction cannot be avoided. Okay, so like forward jumping and all. Okay, so that we will see how we can do that. Okay, forward jump based on the labels and all. Okay, because labels we cannot define like a operand. Okay, right? If we say label for a particular memory location, okay, that can be resolved. Okay, but not like this. What is the first point we are having? Okay, then the third one. To provide some provision for handling forward reference by prohibiting forward references to data items. So if you are avoiding the forward reference for the data item up to certain level, we can avoid this kind of problem. Okay. So there are two ways of or two types of one pass assembler. Okay, up to now we were not knowing like there are two varieties of one pass assemblers are available. Okay, they are much similar. Okay, but working principle will be a bit different. Okay. One that produce object code directly in memory for immediate execution. Okay, so wherever program is available, there itself we are going to generate the object code exactly. But up to now, what we were discussing, like assembler, like program will be triggered for the assembler. Assembler will be generating the object code that will be going for the main memory. From main memory to the processor, finally the execution takes place. So this is what the logic what we were discussing. But here, wherever the program is available, there itself we are generating the object code exactly. Okay, then we are calling it as what? Load and go assembler. Okay, load and go assembler means while loading itself, we will be loading what the object program itself. Okay, we're not loading the assembly level language. Okay, for the execution or for the conversion for the object code. Okay, we'll be loading the object code itself. Okay, how it is possible? If you are generating the object code directly in the memory, then it is possible. Okay, so this variety we are using for particularism. We'll be discussing. We have a next topic. Okay, for what purpose we are doing such step? Okay, we'll be discussing. The other type, okay, produces the usual kind of object code for later execution. Okay, like this will be the usual procedure. Like if you come for assembler, it will generate the object code. Finally, it will be placed in the main memory. Later, from there, it will be executed exactly. So now, first we'll discuss. There is one small difference between these two. Okay, what is the difference? We'll see that. We'll observe that. Okay, load and go assembler. Load and go assembler generates their object code in the memory for immediate execution. Okay, whenever we are expecting the immediate execution, then these type of load and go assembler can be utilized exactly. Okay, so this is the one more functionality of one pass assembler, nothing else. Okay, one object program is written out. Okay, no loader is needed. Okay, so not one, sorry. No object code is written out. Okay, no loader is needed. That's how we are writing the object program or object code for the main memory. Okay, later from there it will be loaded for such type of principle will not be included over here. Okay, so wherever the program is stored, here itself we are generating the object code and it will be directly uploaded for the execution exactly. Okay, so why we are doing this? So, okay, what is the use? So, where we are using this kind of application? It is useful in a system with frequent program development. Okay, observe very careful. Frequent program development and testing procedure. Okay, so here we can use such type of assembler exactly. Means if you are writing the code, okay, for some purpose, and if you want to check it frequently you want to check such type, like wherever the code is available, there itself object code will be generated. They are not involving any long type of a procedure. Okay, there we can utilize the efficiency of the assembler assembly processes is an important consideration. Okay, so efficiency is the main role. The next point also states the same. Program are reassembled nearly every time they are run. Okay, so efficiency of the assembly process is an important consideration. Okay, so we are trying to achieve the efficiency because of that. Okay, so here we got some. Observe very carefully. We got some examples. So here line number we are having, location we are having, source statements we are having along with the object value. So this is one attempt to avoid few forward reference problem over here. Okay, see here we are having a copy means what 1000 it is, then end of file. Observe it, end of file. Okay, means what character output or character input we are providing UOF. What is the value of that? 454 F46. Okay, so these things all whatever we are having here, this should be mentioned at the last actually. Okay, then observe it very carefully. If you are trying to read some value like 3 or return address or length and buffer, okay, then it will be acting like a forward reference. Is it right? Obviously, it will be acting like a forward reference. Okay, but including this in the beginning of the program will avoid the forward references for these type of operand, whatever you are using over here. Return address. Whether we are providing a forward reference over here? No, because return address means 1009. Okay, how many words we are reserving? 1 we are reserving. Here, return address. In the place of return address, what is the operand? Like object code we are mentioning 1009 exactly. Okay, so when we are having length, observe it very careful. Length. Okay, length is having address of 100C exactly. Okay, means these are the operand. Okay, which is declared in the beginning of the program exactly. Now we need to identify. There are some examples here, like red boxes we are having, like return address, end file, then write record, then write record. See, these are the operand which is not defined over here. So they are generating a forward reference problem over here. Okay, see those who are defined under here, okay, they are not generating any forward reference. They are already having the value. Okay, but so these are here we are generating the result. Okay, fine. Okay, but somewhere here, okay, because we are having only line number up to 175. Okay, but if this program is going around like 200 plus line exactly. Okay, so up to here 75, line number 75. Okay, we are not having any information regarding these 4. right? These four boxes are actually write record is repeated exactly. Okay, but when you are comparing, okay, then three different operands we are using, which they are not at all used before, or not, no information is available. But here, just observe, end of file is a label for this particular instruction. Load accumulator EOF. Okay, load accumulator EOF exactly, right? Okay, so now observe very careful. Okay, end of file we are having, but here operand object for what you are generating 2024 exactly. Here 2024 exactly. And for read record also, okay, what you are generating 203D, because this is the location where exactly read record is defined. For write record 2062, this is the location. Okay, in future, this is, see, we have 2036, right? We have 2036 exactly. But here we are having a 203D. Okay, in future we have, okay, we have a description after this. Remember, okay. So now they are updated exactly, right? How it can be done? Okay, that we will see in future. Okay, so these are the few unknown forward references. Okay, like up to certain limit we are avoiding the forward references, but still we are the forward reference. Okay, so we'll see that how we can resolve these kind of forward references. Okay, observe it very careful. Forward reference in one pass assembler. In load and go assemblers, okay, when a forward reference is encountered, observe it very careful. When forward reference is encountered, omits the operand address if the symbol has not yet been defined. See, we are not providing any kind of duplicate address. Fine. See, previously we used to do, in case of a normal assembler, we used to do, what we used to do, we'll be placing the 04 such type of address. Okay, some relative duplicate address we are providing over there. Okay, then later in future, when we are finding that, then that duplicate address will be replaced exactly by using modification record. So that will be a bit complex. Okay, like you need to add modification record, you need to target a particular object for object program. Okay, so that will be a hectic procedure exactly. So just what we are doing, whenever you find such type of format reference, just keep that place empty. Okay, then later enter this undefined symbol into symbol table. Okay, and indicate that it is undefined. Okay, such type of operand if you find with a forward reference, just place it to symbol table. Okay, once you place it to symbol table, then indicate that it is undefined. Indicate that it is undefined. Okay, so we'll be using your operator over there, star operator over there. Okay, star indicates that it will be the forward reference exactly. Okay, then later adds the address of this operand address to the list of forward reference associated with the symbol table. Okay, so we need to add it for the forward reference section exactly, because whenever you are finding the original value of the operand in future, it will be updated exactly. Okay, so now we have information which are under the forward reference. Whenever we get such type of operand address, okay, then it should be updated, right? For that reason, when the definition of the symbol is encountered, scans the reference scans the reference list and insert the address. So the forward reference list what you are maintaining. Okay, so whenever we are finding such type of a symbol, okay, we'll be scanning our reference list exactly. So if that symbol is available, observe very carefully. When you are encountering a definition of a particular symbol, and if the same symbol is available in the forward reference list, then we need to insert the original address. Okay, at the end of the program, reports the error if there are still symbol table entries indicated with undefined symbols. Okay, so when you are finding the end, okay, we are having one more directive called as end. How we are having the start. So when you are finding the end, and if you are still with this some reference or like some symbols, okay, with undefined value, okay, then we have to generate the error symbol. Okay. So for load and go assembler, such symbol table for the symbol name with the end statement, okay, and jumps to this location. Okay, for load and go assembler, such symbol table for the symbol name, okay, in the end statement, and jumps to this location to begin execution if there is no error. Okay, fine. So if there is no error, then what we supposed to do? Okay, see, remember one thing, whenever we are having that end statement, in front of that, we are providing the address of the Address of the what? Beginning location of the same program. What it indicates means during one pass, if everything is fine, if each and every, observe very careful, if each and every symbol is defined, then go for the execution. Okay, so here we can generate the error procedure. Our second option is what we can go for the second pass. We can go for the second pass exactly. Okay, fine. So we'll see that how we can deal with such type. Okay, so here we are having some examples. Just observe. After scanning line 14 of the program, just observe line number 14 over here. Sorry, line number 14. So this is what the line number 14. Okay, line number 14. Jump to C loop. Okay, jump to C loop. Here, just observe 1, 2, 3. So these are the operands which are undefined exactly. Right? Okay. See, after this C loop, end of file is available, and end of file means what? 2024. We can easily identify. But till here, what is the condition of our assembler? We'll discuss that. Okay. So now just observe. After scanning line number 14, in line number 14 with address 2021, jump statement we have C loop, then we are generating this particular statement exactly. Right? Okay. Fine. The status in that the status is that up to this point, the symbol read record is referred once at location 2013. Observe it very careful. Is referred at 2013, end of the file at 201F, and write record at location 201C exactly. Okay, remember this 201C. Okay, none of these symbols are defined. The figure shows that how the pending definition along with their address are included in the symbol table. Okay, so observe it. Here we are having the symbol, okay, table along with the value. For length we have value for 30, then for UOF means what, okay, then read address, return address means what, buffer means what, C loop means what, first means what. So every information we have over there, where they are defined in what particular memory location, regarding that we have the information. But up to line number 14, we don't have information about three aspects. One is what? Read record, second is write record, and third is what? End of file. Next line we have information for the end of the file, but up to 40th line, okay, we don't have information regarding these three. Here, okay. So now just observe what we do over here is, okay, see, read record we have, right? Okay, in front of that value, we will be placing a star, and this dot represents what? Reference. Okay, reference. Okay, this reference indicates where exactly this read record is appearing. Okay, in the program means later if you find the original value of this read record, okay, this is the place where you want to place the original value of read record. Like that for write record, like that for end of the file example. Later, okay. So here 0 you are having, right? Here you have 0, right? So apart from 2013, if read record is defined or the read record is used in one more location, fill that 2020, fill that 2020, then here instead of 0, we need to provide an arrow mark, and same type of list we need to use, and there what we should mention 2020. Okay, means 2013 and 2020 is the two locations where we need to mention the original value of read record. So this is what the information here. Okay, then later the status after scanning line 160, okay, which has encountered the definition of read record and end of the file, is as given below. Okay, so later, like when you are reaching the line number 160, this is the example of what? When you are in line number 40. Okay, so when you are reaching the line number 160, you found that what is the value of read record and what is the value of end of the file exactly. So see here 2024, that is updated, and read record 2030 is updated. But still we are not with the write record exactly. See, according to this slide, okay, see, write record was used only in this location 201F. But when you are moving towards 160, twice you are using this write record exactly. Okay, and later one more we are using means exit. Okay, exit we have, but we don't have information up to now. Up to line number 160, we don't have any information regarding the exit. Okay, that exit is used in 2050. Okay, so regarding that information, we are see in this way we are going to manage the load and go assembler exactly. Okay, like the symbol table will be managed exactly. Okay, no need to go for the second pass. Okay, we'll be managing this separate. So whenever you are finding these operand address, okay, so by managing or by keeping this kind of a logic, we'll be updating the symbol table. That's it. If the symbol table is totally updated, we don't left with any particular value to update, then no need to go for the pass 2. Okay, it is done with pass 1 itself. Okay, so next, if okay, so this is what how we are doing with load and go assembler exactly. But here we are explaining one pass assembler, the normal one. Okay, if one pass assembler need to generate the object code, okay, if the operand contains an undefined symbol, use 0 as the address and write the text record to the object program. See here actually this is what the place. Here is also the place. Here we are having a forward reference, but we don't know what is the value of that. So simply what we do, we will be placing the zeros over there. Okay. Forward reference are entered into a list as in the load and go assembler, same way. Okay. When the definition of a symbol encounters, the assembler generates another text record with the correct operand address of each entry in the reference list. Here, this is what, okay, actually we don't know what exactly this is, okay, and here also we don't know what exactly this is, but when you are reaching this particular place, you got to know like what is the value of this particular operand. Okay, then suddenly what we do, we are adding one more, okay, additional text record over here, which is indicating that, so this value indicates what, 00201C, okay, and the modification like the length is what, 02, then 2024 exactly. Such type will be the alternate arrangement we have in the normal one pass assembler exactly. When loaded, the incorrect address 00 will be updated by the latter text record, okay, containing the symbol definition. So this indicates where exactly, so this record indicates where exactly we should update the content exactly. By using this, what your assembler, okay, when you are loading it for the execution, it will just neglect this 00 and it will be considering this original value itself. So this is how you are the normal assembler, like one pass assembler, used to handle the forward reference. Okay, and this is how your load and go assembler, one pass assembler, used to work exactly. So this is it for now. So in the next session, we'll be discussing regarding multi-pass assembler. Okay, we'll see that how it will be handled or how it will be handling the forward references and such technical problem. Okay, thank you, students. So we'll meet with the next session.